For this first example, I'm going to use the method of the origin step pattern. So we have our base function as f of x equals, or y equals, x squared. In terms of stating the transformations, this function has been reflected on the x-axis, vertically stretched by a factor of 2, and translated 5 units to the right. So our origin, or vertex, is at 5, 0, because those would be the D and C values. Okay, and now we are going to plot down on our graph 2, 4, 6. So 5, 0 is right there. Okay, and then essentially it's like we're creating a new x and y axes right here. Okay, and then our x and y is now transformed to x, negative 2y. And what this means is, essentially, because of this negative 2 here, it's causing our up steps to change by a factor of 2. And instead of moving up, we're actually going to move down now. So that means our points that used to be negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Okay. The x coordinates will stay where they are, no changes. But all of the y coordinates are going to be multiplied by negative 2. So what this means is, from this new xy axes that we've imaginary lines created here, we're going to go negative 2 and then negative 8 down here. So we're going to put our new point down like so. And then from going back to this origin at 5, 0, we're going to go negative 1, negative 2 here. And then 0, 0 is our new origin. So this 0, 0 is where the new vertex is. Okay, so we're not going to plot that point. And then 1, negative 2 would be right there. And then 2, negative 8 would be down here. And then we can create our graph now. Now let's draw our parabola. Like so. Well, let's try the next example. It's another parabola. So again, our base function is y equals x squared. Before we state transformations, we're going to work on equivalent functions here. So what we're going to do is we are going to write this down as y equals half 2 x minus 3 squared plus 1. And now what we're going to do is we're going to apply this exponent of 2 to this coefficient 2 in order to bring out that coefficient from the square brackets. So that means this is going to give us half times 2 squared out of the square brackets, x minus 3 squared plus 1. Okay, so that's the 2 squared we brought out. And what that will allow us to do is this will give us half times 4 x minus 3 squared plus 1, which will then give us 2 x minus 3 squared plus 1. What this means is instead of having originally a vertical compression and a horizontal compression, both by the factor of 1 over 2, we now simply have a vertical stretch by a factor of 2. And then we have a translation of 3 units to the right and 1 unit up. So now let's work on graphing this function. So we're going to put our vertex at 3, 1, and then because we have, so let me write that down under my work, vertex is at 3, 1, and our a value is 2. This means that our steps are going to be 1 unit to the right and 2 units up, and then the next step will be another 1 unit to the right, and usually we would move 3 steps up, but now we're going to move 6 units up because of the fact that our a value of 2 has caused a vertical stretch. Okay, and then we're going to do the same thing on the left side so that our graph is symmetrical. So we have here, here, 2, 4, can't quite fit that last point, so that's fine. We're just going to use these 3 points that we have in order to draw our parabola, like so. So now let's work on this last example on this page, which is the root function. So for the root function, the base is y equals root x. Now, before I state the transformations, I am going to common factor out the half underneath the root. So I'm going to get x plus, this 2 divided by half is the same thing as 2 times 2, so I'll be left with 4. Okay, and that way, when I get back to stating my transformations, I'll be able to say that this has been vertically stretched by a factor of 3, and it's also been horizontally stretched by a factor of 2. And then the last thing I will say is that it's been translated 4 units to the left. In terms of my work for the next part for graphing, my origin is actually at negative 4, 0, because that would be the D and the C value, okay? Origin at D, C. And usually my steps would be to move 1 unit up and then 1 unit to the right. And then my next step would be another 1 unit up and then 3 units to the right. But now this is going to end up changing because of this 3. That's going to affect my up steps. Okay, so instead of moving just 1 unit up each time, I'm going to be moving 3 units up. And then my right steps are going to be affected by this half, which causes a vertical stretch by a factor of 2. So instead of 1 unit to the right or 3 units to the right, I'm now going to be moving 2 units to the right and 6 units to the right. Okay. So this is all starting from my origin at negative 4, 0. So at negative 4, 0, like so, I'm going to move 3 units up, 2 units to the right. And then from that point, I'm going to move another 3 units up, 1, 2, 3, 4, 5, 6 units to the right. And that gives me my transformed function graph. Okay, for the next example, again, we have another root function. So the base is y equals root x. And before we state transformations, we should always try to common factor anything we can. So that'll give us 2 root negative half bracket, and then x plus negative 1 divided by negative half, same thing as negative 1 times negative 2, so it'll be x plus 2, and then plus 3 on the outside. So based on this, we'll be able to state our transformations as the following. We have a vertical stretch by a factor of 2. We have a reflection on the y-axis because the negative is underneath the square root. We have a horizontal stretch by a factor of 2 again. And then we have translation 2 units left and 3 units up. For our work for this function, we are now going to state, first of all, where the new origin is, and that's going to be at D comma C. So it's going to be at negative 2, 3, right there. Okay, and at that new origin, essentially what we're doing is we're creating a new x and y axes, like so. Next, from that origin, we are going to figure out how many units left, right, up, down we need to go to plot our points. So our modified mapping notation for formula will be xy becomes 1 over kx and ay. So what this means is when you take a look at this k value of negative half and you do 1 over negative half, you get negative 2. So that gives us negative 2x. Okay, and then this a value of 2 means that we get 2y. 2y there. Now, This means that our original coordinates, 0, 0, will stay at 0, 0, which makes sense because that has to match up with this origin. So that's fine, nothing's changed. And now for the next point, from 1, 1, we are now going to change this to -2, 2. So this -2, 2 doesn't mean that those are the new coordinates. We're not going to plot our point here at -2, 2. That doesn't make sense. What it actually means is from this new xy axis, as if this is the point 0, 0, we're going to go -2, so 2 units to the left, and then +2, 2 units up. So this is where we're going to plot our next point, right here. And then for the final point, 4, 2, that's going to turn into -8, 4. So again, we're not plotting the coordinates -8, 4. It means that from this xy origin, we're moving 2, 4, 6, 8 units left, 2, 4 units up. So that will be our final point up there. Okay. And from this, we can now create our graph of the root function like so. Let's try to use the same method for the next function, the rational. So for the base, we have y equals 1 over x. For the transformations, we can say that this is going to be a reflection in the x or y axis, doesn't matter which one. Just because this is the rational function, that's why it doesn't matter. Okay, and then we're going to translate 4 units up. And then for our work, so what we're going to do is we're going to put our new origin for the asymptotes at 0, 4. So what this really means is our asymptotes, vertical and horizontal, should intersect at the point 0, 4. So right over here. And then right over here. So you already have your two asymptotes down right now. This is x equals 0, and this is y equals 4. From there, we're now going to look at the reflection as part of our mapping notation, the modified mapping notation. So this means that our x, y is going to become, so we said that we could reflect in either axis, doesn't matter. So let's just choose the y-axis, why not? So then we're going to switch our x to -x, but we're going to keep y as is. So that means all of our original points, -2, -0.5, -1, -1, -0.5, -2, 0.5, 2, 1, 1, and 2, 0.5. All of the x coordinates are going to become positive or negative, so they're going to switch signs. But the y coordinates are going to stay unchanged. Okay. Again, these are not the actual coordinates that these things represent, okay? They actually just represent how many steps you should be moving left, right, up, down from the new asymptote locations, okay? So from our new asymptotes, we're going to move 2 units right, half a unit down, like so. Again, from our asymptote location, we're going to move 1 unit right, 1 unit down, half a unit right, 2 units down, and this completes one arm of my rational graph. Okay, and then I just have to mirror it on the other side. So I get half a unit to the left, 2 units up, 1 unit left, 1 unit up, 2 units left, half a unit up. And that gives me my other rational graph arm. And one more time, just to reiterate where my asymptotes came from. Okay, this plus 4 is the location of my horizontal asymptote, the C value. And this, no translation left or right. That's what causes our vertical asymptote to stay at its original location of x equals 0. So in our last example on this page, again, let's practice one more time our modified mapping notation or step pattern method. Again, we have our base function as y equals 1 over x. Okay. For our transformations, we can state that they are going to be the following. We're going to have a vertical stretch by a factor of 2. We have a horizontal compression by a factor of 1 over 3, 1/3. We have a translation 2 units to the left and 1 unit up. And if you're not sure where I got the 2 units left, it's because we have to take this 3 and factor it out. Okay, so this essentially means that we have y equals 2 over 3x plus 2 plus 1. Okay, so we have our vertical stretch by a factor of 2 right here. We have our horizontal compression by a factor of 1/3 right here. And we have our translation 2 units to the left right here, plus 2. Always have to switch the sign. And then we have our final translation of 1 unit up right here. So again, based on all of this information, we know that our asymptotes or origin will intersect at -2, 1. -2 being the 2 units to the left, and then the 1 being the 1 unit up. So let's start by plotting those points, or plotting those asymptotes down right away. This is at x equals -2 for our 2 units to the left. And then this is going to be our y equals 1 for 1 unit up. So now that we have this, we can work on our modified mapping notation. So we're going to have x, y is now going to become 1/3 x, 1/3 x, and 2y. So what this really means is originally my points would have been at half, 2, 1, 1, and 2, half. And then for the other arm, they would have been at negative 2, negative half, negative 1, negative 1, negative half, negative 2. Okay. But because now we have horizontally compressed our function by a factor of 1/3, that means that all of these points have to move in 1/3 of the way. Okay. And then this 2 means that all of our y values have to be stretched vertically by a factor of 2. So this point right here that used to be at half 2 is now going to be at 1/6, 4. Like there. It's very hard to see. Try it one more time with black pen. Right there. Okay, 1/6 of the way, 4 units up. And now I can erase this point here. Okay. The next point, it used to be at 1 unit to the right, 1 unit up. So now it's going to be at 1/3, 2. And again, once I have that point, I can delete this one. And then the next point that used to be at 2 and half is now going to be at 2/3 of the way and 1. Right there. So again, I can delete this point. And I can draw my curve through these 3 points very carefully. And that'll be the first arm of my graph. And then I can do the same thing with these points here. And that gives me this arm of my graph right here. Okay. And if you're not sure of how I moved those points, I will just show you the modified mapping notation formula again here. So xy, it will become 1/3 x and 2y. So then I'm going to end up having negative 2, negative half, turn into negative 2/3, negative 1. Negative 1, negative 1 is going to turn into negative 1/3, negative 2. The negative half, negative 2 will turn into negative 1/6, negative 4. Half 2 will turn into 1/6, 4. One is going to turn into 1/3, 2, and then 2 half is going to turn into 2/3, 1. And that concludes our step pattern method. For the last page of examples, because those are not regular functions, they're just kind of pieces of other functions put together, I would recommend that you use mapping notation. So for that, you can watch the mapping notation video. half.